So if I look at the meter, if you first turn your meters on, just put it on voltage, if you would, everybody turn their meter on. You can see it comes up is, you'll normally get all kind of pictures. Some of these will say BAT. Bottom line gets to be if they say BAT or they say show you picture of the battery, that says, hey guys, your 9-volt transistor battery's bad. And guess what? You don't have enough power to forward bias to all the electronics on that deal. Guess what you got to do? You got to change your battery. So if you look inside most of these meters, there's 4 screws. We're not going to take them apart today. But you got a 9-volt transistor battery in every one of these meters. Okay? Now, what should you do twice a year?
Replace it.
I don't even know if you need to replace it. But what you need, you ever forgot about batteries? You open them up and everything's green and corroded on the inside where the battery leached? So guess what you should probably at least do is open it up and look, because they'll oxidize on the terminal. So what you do, just unplug the battery and plug it back up. Look at the damn battery. What do they cost, $2? You gonna let a $2 battery eat your meter? Might not be a bad deal just to change it out as a matter of course. Once a year, put a little date to it. It says, hey, in June I gotta check my battery. But don't forget, there is a battery in there. Now, all your meters have what we call gray screens. If you forget to turn it off, what we'll do? It shuts down. Takes about a minute for that. That's to keep them from running your batteries down. But they will eventually, your batteries will get bad, so you need to check your batteries. I say twice a year, simply because you don't want that battery in there to corrode, get green stuff, and cause corrosion, cause problems on your board inside of the unit. Okay. All right. Now we've come to conclusions that nobody had a battery sign, right? Nobody said BAT, so we know our batteries are good, right? Now the first thing you want to do before you use these meters is turn them all the way to ohms. That's a Greek letter omega. Okay. Perfect. Kyle, right?
Curtis.
Curtis, God, I'll be all right.
You're cool.
Curtis, and look how Curtis is holding his deals. What I don't want you to do when you check these is don't use your thumb and your body. Look what he did. He put his together, and what should your meter read? Somewhere about 0.1 to 0 should say that the meter's good, right? And has everybody got that on their meters? Mine says 0. So what's that tell me? It tells me my leads are all good. If the leads haven't been good, guess what? You'll bend them here, and they'll break here, they'll break here, and they'll break right here where they get bent. If you had one that did not go to, if you see on the left, it says 0.3, and you see the one on the right, it said up to 0.2, is obviously I got a problem. Either I got a problem with the leads or got a problem with the meter. Because if it's this far off on a 0 point, what's going to happen when you get into sensors and things like that you got where you're up to 8 megs or whatever, you're going to be way to hell off the farther up. So you want to make sure every time you use this meter, you zero your meter, make sure your meter zeroes out. Now, this is an Arkansas fix. You take a paper clip, if it didn't zero out, and you just simply put a paper clip in there, or you could put a piece of wire. It doesn't matter what am I doing? I'm bypassing everything. So if the meter went to 0, I know it isn't the leads, is it? I know I got a good meter. Now if I look on this side and I'm at 0.5, what's that tell me? Meter's bad, so guess what? It's high, whether it's 2 years or not, meter needs to go back to flute because it's nothing you guys can be able to fix. It's going to have to be fixed by the manufacturer. He's going to have to check the gain, everything else on this, and go back and calibrate your machine because it's not working like it should. Okay? Now, if it zeroed out and you still had a high voltage, you can see on this one, look what I did. I took the black lead out, right? And I took my red lead and I put the black lead, so what am I really doing? I'm just making a loop, aren't I? And it should be pretty well 0. If it said 0, or you can look on the left, I'm saying 0.7, I just threw these numbers up here. But you see the one on the right says that that's what it should read. And that's just a real quick way of finding out if it's your leads or not. Here's checking the black light. You know, if you check the red, you're going to have to check the black too. So you can see here, I'm way out of spec on the left. And you can see on the right, I'm back to 0 so that I know I got good leads. Now, will you have to go to this extent every time? No, because what should happen when you put your leads together? Pretty well should 0, right? But that's, you just want to make sure that you do that. If you're out with a customer, you know, don't forget to ask him those kind of things. If you guys are talking to people on the phone, don't assume his meter works, because that's a bad assumption if you do, and you can make decisions based on what he tells you, and guess what? He could be telling you the God honest truth. He just got a bad meter that doesn't do what it needs to do. Now, there's lots of different functions. All these are going to be a little bit different, but I'm going to show you, if you go back over here to put your meters on voltage DC right now. That's the straight line with the dotted line underneath it, okay? Now, it'll come back and tell you voltage DC on here, but if you have no signs, this means this is an automatic ranging meter. Every one of you've got an automatic ranging meter. This means this meter will go, if I remember my numbers right, this will go up to about 600 volts DC. And if you're working 600 volts DC, God bless you, be very, very careful. But by the same token, the meter knows what to go to. So if you bought an automatic ranging meter, what should you do? Use the damn thing, and it will automatically go to the right scale, okay? Now, if you think you're smarter than the meter, and this particular one has a little button in the middle, I can hit the button on this one here, look at my range. See where my decimal places are, guys? Everybody see this? Watch. Hit my decimal place. See it move? See it move? Can you see it move? See, I hit my range button, I make my decimal place move. Now, right now I said it'll never see more than 4 volts, right? If I hook this across the battery, what would it read? What would my meter say? Would I hurt my meter? No. What will it say?
4.
No, it'll say, oh well, it'll say out of luck. And let me tell you where that gets you in trouble. Let's say your wife knows or your girlfriend knows you have one of these meters and she's got a plug at home that isn't working. Says, bring that home and fix it, honey. So you go over and put it on AC. And you think you're a little smarter, so you put it on here. Now it says it's only going to see 40 volts AC. And you stick it in a wall plug. If a wall plug's hot, what's it typically going to read? 120. So what will it read? OL. So what will you assume? There's no power. When you stick your hand in there and scream, it's not because the meter lied to you. You put it on the wrong scale, and it told you what? It just, OL doesn't mean there's nothing there. OL says you're out of luck or out of limits, but you're over the limit. So my point gets to be, when you go to use one of these meters, turn it back off and turn it back on. And where are you at right now? You're back on automatic range. Now, there's another function on all these meters. This one, you'd hold it in for a couple seconds. On this, see where it says hold? It'll come back, and then I get the little symbol that says hold on the top. Now, this is one, let's say that you're doing something. I'm trying to think of things you would maybe potentially, let me just example. Let's say I had a blower motor or something I'm trying to check, see what the voltage is as soon as I turn it on. But I can't be here and see the meter at the same time, right? If you put this on hold, as soon as it sees the stabilized voltage, you'll hear a beep, and it'll lock a value. When you walk back, there's the value you just picked up when you did that. For example, I got some 9-volt transistor batteries. I'm going to let you guys play with it a little bit, but I got this on touch hold right now. You agree? Look, I'm going to just touch across this battery. See what it did? And when it sees another stabilized voltage, it's a great trick for you guys, because there's a lot of times you're going to be, how can I be at 3 places at once, right? So if you use touch hold, as soon as it sees that voltage stabilize, it will come back and do it again. Yours would be, see your hold button here? Mm-hmm. See where it comes up, it says hold? And you got a min and max? Do you have a hold? Min-max. You only have a min max on yours. Okay. You got a hold button on yours. There's your purple one, right? And if you hit, see it's already, it says hold, and you got a purple in yours, it says hold, okay? Great trick. Now, if you forget, leave it on touch hold, you'll be trying to work on something, it'll keep beeping at you, and you'll see some wacky readings, you think, and it's not the meter, it's the guy driving the wheel, probably put it on the wrong scale. So if you want to get it off those things, easiest way, just turn it off, turn it back on, and it automatically goes and will scroll to where you want it to be, okay? Oh, these are usually AC. Normally, when I work with truck fleets, we never talk about AC, but here's the problem with AC anymore. Any sensors, you never know if they're going to be DC. Most of them will be DC, but you got some AC ones out. Right now, like I know Navistar has a throttle position sensor that has AC input, DC output. But if it's AC, guess what you're going to have to be on if you're going to truly going to measure that. You can't assume everything's DC, especially in today's electronics. You got to look. Because if I had something that was AC signal, it means I'm doing it at 60 hertz, right? And it's looking for that waveform. If you had on DC, what would your meter probably read? Somewhere close to zero, because it's going to take the average, isn't it? So it's going to say, well, I don't have anything there. When it's not that, it's just simply you've got the voltmeter on the wrong scale. Okay. 99% of the time, do you guys have anything on any of your sensors AC, or you're all DC?
Our wheel speed sensors.
They are AC?
Oh, yeah. He's got that tooth wheel where it's got the gap, the gap, the tooth, so you get the alternating current.
So they have to be able to have an AC meter if you're going to go back and check it. But again, those are things that people forget about it, and they'll just flip it on DC and say it doesn't work. Well, you're never going to see any of that movement, are you, if it's on a DC and it's supposed to be AC. So I'm going to spend most of my time today talking to you about DC. And DC, would you move it up to here? And now, guys, if you go up here to see where it says millivolts, that means, everybody know what a millivolt is? That's a thousandth of a volt. In this case, these meters usually go to about 300 millivolts. So you're not going to hurt the meter if you put them on 300 millivolts, and I hooked it across the battery, but what's going to read? Well, because you're going to be way to hell over the limits. 300 millivolts is 0.3 volts. So that's not very much. Yes?
I think, does this one tell me then that it's 6 millivolts because it's got the bar across
Yeah,
the
because
bottom?
right now, see, it's just searching.
Right,
A lot of
yeah.
times they go crazy, but see the little M and the V?
Yeah.
You're on millivolts right now.
Yeah, but I'm looking at the scale. It's got the scale across
Mhm.
the bottom, and it's got that 6.00. It's got the bar scale. Would that indicate that this is 6 millivolt?
Well, see, it just, right now, it's just I'd have to look at your manual to see exactly. Okay. They're just trying to give you when they tell you that, when you go to that millivolt, see how mine's doing that, it's just looking for a signal.
Yeah, okay.
And then the scale will kind of tell you where you are, which scale they picked for you. But again, you're going to get all that fluctuation, whatever, when you're on millivolts. I don't know, are you going to be using millivolts for your products?
Yeah, I have.
You have on certain things, if you're just trying to look what your input is?
The alarms. The alarm on it, the siren.
Yeah, so, it just depends on what you're going to use, those type of device. But remember, you're going to have to look at your meter, look at your manual, whatever, because all of them are going to be different. But I would say usually these are going to go up to about 300 millivolts is all they're going to run to on that scale, okay? Most of the time, where you're going to go? You're going to go to where it says voltage DC. The meter will even come back and say VDC, so you're on voltage, okay? So let's look at all the ways you can use a voltmeter, because I want to show you, first of all, how people tend to use a voltmeter. People tend to use a voltmeter, they put it across the battery, for example. They always want to go positive to negative. That's how everybody wants to use a voltmeter. In this example, I got a battery that we know ground is always at zero potential, right? Zero is always going to be at the battery negative, right? So if I look at this, remember this, what a voltmeter does, guys. If my body's a voltmeter, red lead, black lead, all I ever tell you is the difference between the 2 points you put it at. I only tell you the difference. So in this case, I got 0 on the ground side, and I got 12.5 on the positive side. What's the difference? 12.5. So guess what the meter reads? 12.5. Now, I can have those leads, and I'm showing a starter, but it could have been your ABS module, right? And I have leads that go all the way to that starter. Nothing's happening. It's just sitting there, static. Remember I said you can have voltage error? So if I put that voltmeter all the way on the starter, hot side of that starter battery post, and to ground, again, I'm sorry, I went too hot. I went, hold on, I went one too many. No, I didn't. I guess where I did. But I went from hot to hot because nobody typically does that, do they? It doesn't hurt the meter a bit because I put that voltmeter in parallel. But the reason it reads 0 is not because there's nothing there. I've got 12.5 on one side. I got 12.5 on the other side, right? So what would a meter read? It would read 0 because what's the difference? Is there any difference? What should you see? If I took, for example, unplugged the module at the trailer, right, and took the blue wire, your power lead coming off the aux pin, and went from aux pin that's hot and went back to where I pulled that off on your ABS system, what should it read when unplugged? Should read 0 every single time because I don't have any voltage drop because there's no current flowing. But I should have voltage there, shouldn't I? And it could be 100 miles long. If there's no current flowing, I'm still going to have the same voltage potential on both sides. That's the key. The voltage potential's there. You don't believe me, put a screwdriver or something where you go to ground and see how quick the sparks fly. The potential's there, just nothing's happening. Okay? Now, can I take that same meter, go across the starter? Again, I'm at 12.5 at the positive side, I'm a 0 at the other side. So what's the difference? It's 12.5. Okay. Now I can go from ground on the starter to positive of the battery. Again, it's still fundamentally still the difference. Okay. Now let me show you what happens when you really get. This is all with no current flow. I went from ground to ground, 0 both sides, so my meter reads 0. Now in this case, let's say I got 1,000 amps going from the battery to the starter and back. Okay, you can see how the current's flowing. Everybody agree the current's flowing. Whatever current flows from the positive, look at what my first voltmeter. My voltmeter reads 8.5. And the reason it reads 8.5, again, I got to see 0 at the battery ground. Everybody agree? Right? And I'm reading 8.5 because that's what the voltage dropped to under that load. Okay? So the difference would be 8.5 volts. That's what my meter shows me. Okay? Now look at your starter. Remember, it was the same. Now under load, I'm only seeing 7 volts at the positive side of that starter, and I'm seeing 0.3 at the ground side. So the difference between 7 and 7.3 would be 6.7. So I look at those, I got 8.5 at the battery, I got 6.7 at the starter, or it could be your ABS module. How can I have that difference? That's exactly right. Where's all that loss at? It's in the cable somewhere, isn't it? Now, if I wanted to find out where that resistance is, look what I have to do. You can see I went from 8.5 to 7 volts, right, in that example. So what would my meter read? 1.5. So if I had 1.8 total, because look, remember I said I had 0.3 at the ground post of the starter? And then I had 0 at the battery, so what does that tell me? I got 0.3 volt drop on the ground side. On this one, where's all my voltage drop? My example. It's in the positive side. So which side would I work on first? Positive side. That's the one that's got the biggest voltage drop. But nobody uses a voltmeter like this. Now, how would you do this on your system? How you going to make this work? Can't run beside the truck or underneath the trailer when it's working. Can you guys make that thing pull current and go through its cycle? If you do, you're going to have to make some sort of interface because you want somebody punching a hole at the end of your wire to see what it is before it goes in your module. How are you going to do that? make an adapter. You know, use common sense. We're working with trailer techs right now that the lighting people tells us 60% of all the lights they get back, guess what's wrong with them? Nothing. Something's wrong with the trailer. They didn't light, so they just try a new light. That didn't work, now they gotta work on the trailer, right? But then what's the easiest thing to do? Put a new light in. Same things can be applicable with you guys is if you know, I was talking to Bob once, he said, you guys paid a lot of money on flat spotted tires. And guess what? The culprit might be 200 miles down the road pulling another trailer. Because by the time you get there, what do you get to look at? You get to look at the trailer, right? Because he's got the trailer that caused all the issues. And guess what? You can't find a damn thing wrong with the trailer. The problem is it ain't hooked up to the same tractor that it did when it had all the problem. And the tractors is the fall guy. You go into any shop in America, and every maintenance shop, whether the good ones like Hunt and the Walmarts are real, they might have some real fancy equipment to do all the tests. Most people build homemade ones, and I don't have anything wrong with homemade tests. But everybody checks lights, because what do? They plug in a power source and they look up to see if the damn light's on. Everybody agree? How many guys ever check the tractor assembly? Because what do they assume?
It works.
It works. If you really want to see a real funny fight, is go to some place where they got a Penske tractor and a Ryder trailer, and the lights don't work. You'll get these because it's your fault. No, it's your fault. Whatever is. But again, I can almost assure you, everybody checks the trailer by adding power when it's sitting in the shop. Who checks the tractor? And they're terrible. They're not any good new anymore.
I had a service truck. We hooked up to a trailer. We were going to check the lights, and there was no power. This was the service vehicle.
Yeah. I would estimate that we did a survey a while back, and we looked at good fleets. And 30% of all the aux pin are blown. Well, how would they know? Everything works. It's going to work off break. Don't work as good. It only takes one bad trailer to wipe out thousands of fuses, because every time you plug up, what happens? You don't hear it. It's there. Now, I told you that I'm going to let you have some stuff to play. All right, here's your toys. These aren't very sophisticated, but what I want you to do is, if you'll plug the lights in, look, if I gave you a battery that works, if you do this, look what should happen. Light should come on. Everybody agree? Your light come on? If the light comes on,